Hi, good day all of you. Welcome to our session. Welcome to our channel, Intelligible Tutorials. In this today's session, now we are going to describe about the Boolean algebra. In my past video, I described regarding the logic-based testing and the path expressions in the STM. And now I am going to describe about the Boolean algebra. So, what are the rules and laws are there in the Boolean algebra? How the laws can be represented in the Boolean algebra? All these things now we are going to see. So, let us see first here. So each and every decision or label can be represented in the uppercase letter here. So that represents the truth value of the predicate. So the S or true branch is labeled with A. So whenever we are saying the value A, that is true A, we can represent it as A like this. And no can be represented by the overscored A like this. Okay, so false branch or no can be represented by using this overscored A. The truth value of the path is the product of individual labels. Okay, concatenation or product means AND. The two or more paths merged at node. The fact is expressed by the use of plus sign. The plus means OR. Okay, so the concatenation can be represented as and this or that can be represented as OR. That can be represented as plus. Okay, and can be represented simply, it's a product. It can be represented as, and R can be represented by using the plus symbol, right? So now how it can be represented, now we see. Let us see, this is a big troublesome program. So the program can be started at the root number 1. Start node is the node 1, and node 2 is the end node. In between we are having node 8, node 6, node 12 and node 11 are the nodes are there. Okay, and action 1, action 2, action 3 are the 3 actions, and A, B, C are the conditions we have. Okay, so using this convention, the truth functional values for several nodes can be expressed in terms of the segments from the previous nodes. Use the node name to identify the point. For example, node 6. Okay, so how this node 6 can be represented here? This is the node 6. The node 6 can be represented A plus A bar into B bar into C bar. So A bar and B bar and C bar. It's a product actually. So how it can be represented now? We see in this particular diagram. Sorry. See here. Node 6 can be represented A plus A bar plus B bar A plus A bar plus B bar plus C bar. Okay. So that is the node 6. Node 8 is N6 into B plus A bar plus B bar. So how the node 8 can be represented? Node 8, this is the node 8. N6 plus A bar plus B. So this is conjunction with this is added with 6 also. So it is connected with 6 also. Node 8 can be represented as N6 plus N6 into B plus A bar into B. So N6 into here we are having B plus A bar into B. Okay, so A bar into B, this one. Okay, so how it can be represented? Just expand this. N6 is what? A plus A bar into B bar plus B bar. We expand this, that is A into B plus A bar plus B bar plus C bar into B, A bar into B. So this is the term we got finally after simplification. Now N11, that is the node 11. So what is the node 11 here? Node 11 is represented as, it is added N8 with into C plus N6 into B into C. N8, this is the N8 into C plus N6 into B bar into C. N6 into B bar into C. So these things it contain, that is the node 11. So it can be represented, this is N8 into C, N6 into B bar into C bar, B bar into C. Now N12, where is the node 12 here? This is the node 12. So how node 12 can be represented? Node 12 is, sorry, node 2. Node 2 can be represented. Node 2 is conjuncted with N12. So N12 plus N8 into C bar, N8 into C bar plus n6 into b bar into c bar. So n6 into b bar into c bar, this one. So this is the representation of the n2. Okay, so we can simplify this by using certain number of the rules. Okay, so now what are the rules of the Boolean algebra? Okay, so in the Boolean algebra, normally we use only two numbers, that is either 0 or 1. 0 represents always false, whereas 1 represents always true. And it also implemented by using three number of operators, and or not. And can be represented as the cross mark, that is product, or can be represented as plus and not. So cross mark means the end. It also called as the multiplication. A statement such as AB is represented as A into B. That is true. That is represented in the Boolean algebra as A and B are both true. This symbol is usually left out in the ordinary algebra. Okay, so A and B, A cross B means A and B, that represents both the statements are true. Okay, A bar plus meaning A or B. So A bar plus means what? A or B. Either A is true or B is true. So plus means A or B. Either A is true or B is true. Now what is A bar? Means not. So also negation or complementation of the A. This is represented, A bar is represented as not A or A bar. The entire expression under the bar is negated. So like this we are having cross for and both are true, plus either A or B are true. A bar means not A or not true. Okay. So like that the rules of the Boolean algebra can be represented. Now let us see some of the laws of the Boolean algebra. That is A plus A is equal to A. Okay. And A bar plus A bar is equal to A bar. A bar plus 1 is equal to 1. If something is always true, then either A or true or both must also be universally true. And A bar, A plus 0 is equal to A plus B is equal to B plus A. This is a commutative law. And A plus A bar is equal to 1. Either A is true or not A is true, then the statement is always true. Okay, so A plus A bar. Next, A into A is equal to A bar into A bar is equal to A bar, A and 1 is equal to A and 0 is equal to 0, AB is equal to BA, the commutative law, and A into A bar is equal to 0, and A bar is equal to A. 0 bar is equal to 1 and 1 bar is equal to 0. A plus B whole bar is equal to A bar into B bar. Okay, it is also called as De Morgan theorem or law. A into B bar whole bar is equal to A bar plus B bar. And now we are going to describe about the distributive law, that is A plus B or C. A into B plus C, that is A and B or C. So AB, A into B, A and B plus A and C, either A and B or A and C. So this is the distributive law. Next we are going to discuss about A into B, A into B into C. So it can be represented as A into BC. So this is the multiplicative or associative law. Next we are going to see the addition associative law, that is A plus B plus A plus B plus C, A plus B plus C. So now we are talking about the last law, that is absorption law. So A plus A bar B is equal to A plus B. A bar is absorbed here. So A plus AB is equal to A. AB is absorbed here. So this is called as absorptive law. Like that, the following laws are there in the Boolean algebra. So we have to remember some of the known laws to priorly we know are commutative law, the absorption law, and De Morgan's law and distributive law. These laws already we know, and these are the other kind of the new laws they are used in the Boolean algebra. Okay, so in the all of the above, whatever the letter that can be represented single sentence, either Boolean, entire Boolean, or an entire Boolean algebra expression. See, these are called as, the single sentences are called as what? Boolean expressions or logical expressions. So individual letters are called as literals. See here we are having the A bar like that. These are called as the literals. So whenever we are having the combination of the literals, these are called as what? The product terms. Okay, so product of several literals are called as product terms, and the collection of combination of these literals, either products or sums, whatever it is, we call them as the Boolean expression. So this is one of the Boolean expression, which is a combination of A, B, and C, and the operations as into and addition, or operations as or and end. Okay, so product of several literals are called as product term. A into B into C, D into E. Then arbitrary Boolean expression that has multiplied out, so it consists of sum of products. This is the example of a product term C. A into B into C. This is the example of sum of these products, that is A into B into C plus D into E into F plus GH. So where we have used in between plus symbol, so that's why it is called as sum of products. Product of sum means sum, whenever we use the into in between, that is called as product of sums. The result of simplifications using the rules above gain sum of products form of each product term simplified as prime implicant. So what are the prime implicants here? For example, ABC plus AB plus DEF. We reduce to AB plus DEF. That means we reduced AB C plus AB by using the absorption law. What it is saying, the law, that is the absorption law, rule number 20 here. See, in the rule number 20, what it is saying, A plus AB, A into B is equal to A. So it is one kind of absorption law. So here what we absorbed AB, ABC plus AB. So we reduced it into AB plus DEF. That is AB and DEF are called as the prime implicants in this particular exception, in this particular expression. The path expressions of this figure of the following can be simplified by using some set of the rules. So like that, we can say the individual letters are called as literals. The combination are called as the expressions, and that can be represented as a product term, sum of product term, and prime implicants. We can absorb this by using absorption law. So we can get in this particular expression as AB plus DEF. Here AB and DEF are called as the prime implicants. Okay, now let us see some examples of this. The following are the rules in the Boolean rules of this. How can we implement this particular one? In the previous one, we have seen what is the N6. N6 is equal to what? A plus A bar into B bar into C bar, right? So A plus A bar into B bar plus C bar. So use rule number 19, that is absorption law. What is the rule number 19? It is saying, sorry, the rule number 19 previously, A plus A bar into B is equal to A plus B. Okay, absorptive law. It is also one kind of absorptive law. So A plus A bar are absorbed here. So A bar is absorbed here. So we got A B bar into C bar. So the resultant is A plus B bar into C bar. Now coming to the N8, that is N6 into B plus A bar into B. Let us see in the previous one what is N8 here. N6 into B plus A bar into B. Right? So how it can be simplified, now we are going to see. Let us see N6 into B. N8 is what? N6 into B plus A bar into B. So what is N6 here? A plus A bar into B bar into C bar. Right? So I have taken B into B plus A bar into B. So we have simplified the N6 now. So what is the resultant? We got A plus B bar C bar. So I have substituted this value in place of N6, that is A plus B bar into C bar into B plus A bar into B. So what we got? AB. We have expanded it. B bar into C bar into B plus A bar into B bar. AB plus, here we got only the C. B into B cancel, B bar cancel, C, A bar into B. So AB plus 0. B into B bar what? So according to the rules, what we have seen in this particular rule, see, B A into A bar. What it is showing? A into A bar, that is 0. Like that, B into B bar is equal to 0 according to the rule number 10 I am saying. See, let us see here. A into, 1 minute, that is A B plus 0 into A bar into B. That is B into B bar is 0. Right? According to rule number 10. AB plus 0 into A bar plus B. So what can we take common here? That is nothing but B into common. That is A into A plus A bar. So what is the value of this A plus A bar? The value of A plus A bar is nothing but 1 according to the rule number 5. Right? So according to the rule number 5, a plus a bar is equal to 1, 1 into b is equal to b. So like that we have simplified that n6 n8 into b, whereas n6 into a plus b bar into c bar, right? So everything is we have to take in into the this particular rules only. The 20 rules are very very important to simplify any kind of the Boolean expression, right? So the next one is n11. So the next one is n11. So what is the n11? According to the n11, what we have seen, according to the n11, what we have seen in the previous one, that is just a minute, n11 is equal to n8 into c, just a minute, n8 into c plus n6 into b bar into c. Okay, so how can we represent this n8? N8 is nothing but sorry, n11. N11, what we have seen the n11 in the previous, n8 into c plus n6 into b bar plus c, this one n11, just a minute. Okay, so now we are going to simplify this n11. What this n11? N8 into c plus n6 into b bar into c. So what is n8 here? We simplified the n8 now. So what is the n8 here? We simplified, we got here it is b, right? So b into c plus, what is n6? We simplified this one also. N6 is a plus b bar into c bar. Okay, a plus b bar into c bar. Okay, so a plus b bar into c bar into b bar into c bar. We have substituted this. Now we are applying rule number 16, 9, 10, 18. So what is the rule number 16, 9, 10, 8, 3? In the table, what are they? 16, 9, 10, 8, 3. 16. What the 16 is saying? It's a distributive law. 9, a b is equal to b a. 8, a into 0 is equal to 0. 3 is nothing but a plus 0 is equal to a. So we have to substitute all these rules. So bc is equal to bc. So we have substituted a into b bar plus b bar c bar b bar c. So we got the resultant as b into b bar is equal to what? B is equal to c bar. So what is b into b bar? E into b bar, 0. So one term cancelled, that is 0. So what the resultant we got? B into b bar get cancelled here. So in a bar, a into b bar plus c is the resultant one. So what is the common thing we take here? B plus b bar a. So whenever we take this common thing, that is b plus a, b bar is absorbed here according to the rule number 19. So it is a distributive law, bc plus ac, that is bc plus ac. Now n12 is equal to what? In the previous n12 we have seen, what is the n12? N11 plus a bar into b bar into c bar. Okay, so what is the n12 now? We have seen, see in the previous one we have seen, that is just a minute, n12. See here we have seen n11 plus a bar into b bar into c, right? So that is the n12. N11 plus a bar into b bar into c. So what is n11? ac plus bc plus a bar into b bar into c. So we take the c into the common, then we got b plus a bar b bar plus ac. So c is equal to a bar plus b. So it is absorption law. It was absorbed, a bar plus b plus ac. So c into a bar plus ac plus bc. Again I have taken c as the common one. A plus a bar is equal to 1. So c into 1 is equal to c, that is c plus bc, that is c, we got n12. Now I am going to describe about n2. So what is n2? In the previous one we got, sorry, n2 is equal to what? N2 is equal to what we have seen, that is n12 plus n8 into c bar plus n6 into b bar plus c. Okay, so that is what? N2, n12 plus what it is showing, n12, just a minute, n12 plus n8 into c bar plus n6 into b bar c bar. So what is n12 here? C. So c bar. What is n8 here? We got from the past video, n8 is equal to n8 is equal to b. N8 was simplified as b. So b into, just a minute, b into c bar plus what is n6 as per the past? N6 is a plus b bar c bar, right? So n6, just a minute, n6 is equal to a plus b bar into c bar into b bar into c bar. Now just expand it and apply those rules. That is c plus b into c bar. We have to substitute, we have to distribute this one only using the distributive law. A bar, a plus b bar into b bar, b bar into b bar, c bar into c bar, that is cancelled. And next finally we got b bar into c bar. So c plus b bar, b bar in b into c bar plus b bar into c bar. So c plus c bar, if I take c bar into common, b plus b bar. So b plus b bar is equal to 1. C plus c bar is equal to c plus c bar into 1. So c plus c bar is again 1. So n2 value gets as 1. So what are the values now we got? That is nothing but n6 is equal to a plus b bar plus c bar, and n8 is equal to simply b we got, and n12 is equal to c we got. So the loops, what are the previous values we got for this is b plus a bar into c bar for n8, n12 is equal to c plus a bar into b bar. So by simplification we got these simple values like b and c. So the loops complicate the things because we may have to solve the Boolean equations to determine what predicate value the combinations will lead to here. So what we have to do here is nothing but we have to simplify in the form of this kind of the expressions. We have to remember this number of the rules. Based on this number of the rules, we have to simplify these expressions. And finally, we can know what is the output of this particular node, each and every node we should know. Okay, so we can simplify this output of these nodes by using these logical expressions, by using these 20 number of the rules. You have to remember all these Boolean laws. Okay, all Boolean algebra laws in order to simplify this number of the expressions. So all the nodes we have some simplified forms like n6, n8, n11, n12, and n2 are simplified like this. Okay, we may confuse with the loops. These loops can complicate the things. Okay, so like this we have to simplify this particular Boolean expressions. In the coming video we discuss about the KV charts. What are the KV charts, how they are going to be represented. If at all anybody didn't subscribe my channel, please subscribe my channel, Intelligible Tutorials. Thank you one and all.